Hello everybody, today we're going to talk about entropy. Entropy is basically a probability of energy configuration. So let's think about something like this. We have two solid objects each are made up with four atoms and 6 atomic bonds like this. Like that. And we're gonna have two of them. And so, well, the circle thingies are the atoms and the squiggly stuff are the atomic bonds. And let's say this is energy. We're gonna call it quanta, and we're gonna have a total of 8 quanta. 6 quanta over here. The quantas sit on the atomic bonds, and we're gonna have 2 quanta over here. So now we have a total of 8 quanta, and these two solid objects, they're right next to each other. Now the entropy here is the probability of the configuration of the quantas. So, well, 6 could be here and 2 could be here, like this is right now. And there could be 4 over here and 4 over here, the same amount. And there could be 3 over here, 5 over here, or 5 over here, 3 over here. Or 1 quanta might move towards here, and there will be 7 quanta here, 1 quanta here, or 8 and 0. But well, there's a lot of configurations that can happen, and now the entropy is the probability of that. So now all 8 quanta going onto one side, that would have a low probability. Just think about it. It would have a kind of a low probability, and well, it would be the same for the other one too, all moving towards that one. But 3 and 5 quanta on each side, or 4 and 4, that would have a kind of a higher probability. With 6 atomic bonds and 8 quanta, we have over 9,000 things that can happen. Over 9,000 possible configurations. And if we calculate probability of the configurations, as I said, the one with the similar amounts have the higher probabilities. One solid having way more quanta than the other one, those have the lower probabilities. It's gonna look something like this, and this is a part where it would be 8 to 0, and this is a part where it would be 4 and 4, and this is a part where it would be 0 and 8 quantas. And now here the 4 and 4 situation, this has about 21% chance of it happening, and now this one has the highest probability, and that means higher entropy. And the world likes to have stuff with higher entropy. So if I hold this pen up here, it has potential energy. And if I let go of it, the potential energy drops and it moves into kinetic energy, and then it converts into heat energy and so on. But now as I drop the pen, with heat, the energy spreads out. And spreading out means higher entropy. Like, well, you can see it's spreading out, and so it's equally distributed. That has the highest probability. So if I do something, I mean, the physics of this universe likes to move towards the higher entropy state. And also we can see over here, well, before that, there, let's say somewhere around here is the 7 quanta here and 1 quanta here. that state, this has, in this situation, about 8% of chance of happening. But that means there's a 8% chance of the solid with the less energy giving a energy to the solid with the higher energy. But we never see a hot mug of tea getting hotter, so how can that have any probability of happening? The hotter one getting more energy. But now we have to think that these are very small solids. We have only 4 atomic bonds each, so these are very small. But just think of this pen. How much atoms are gonna be in here? There's a lot. There's a lot of atoms in here, and unbelievably many atoms, and that will make it so that the probability look a bit like this. Kind of poor drawing, but whatever. But now, with something gaining energy when it has already lots of energy would have almost 0% of chance happening, because there are so much probability of stuff that could happen, because there are a lot of atoms and a lot of atomic bonds. But where the energy moves from the higher energy state to the lower energy state, that would have a lot of chance of happening. So basically, entropy is basically a probability of energy configuration like this, and the world likes to move from lower entropy to higher entropy. So if we draw the whole universe timeline like a little bit like this, here's the Big Bang and it's expanding. This has very low entropy. All the energy in the world is just mushed into one dot, one little singularity. But now it expands and the energy is more spread out like that, and now we can see here the universe is moving towards the higher entropy state. So we can see here that the entropy is the arrow of time. And I think that's basically all that I wanted to talk about entropy today. So, bye.